Hello everyone. As you can see here in the picture, there are different electrical appliances. Like these two are known as the electric room heaters. This is the electric toaster and it's a bulb. In all these three to four pictures that you can see these red hot wires, right? They are called as the resistance wire inside the appliances, and we are using this heat which has been released for as a workable. Like in the room heater, the heat released by these red hot wire is being used to keep the room warm. Same way here, the wire is heated up. The heat is used to cook the bread or you just toast your bread. Okay. And here the heat released by the filament after getting heated up is used to glow. That's how the bulb glows. We'll be talking about the working of the bulb a little bit later. But what is happening here? The wire, this is which is used as a resistance wire, it gets heated up when current passes through it. For example, if I give in a day-to-day example, when nowadays you are doing these online classes, so you'll be sitting in your computer or laptop for many hours, let's say 4 to 5 hours. After 4 to 5 hours, if you try to, even today you can try it, if you try to touch your laptop or your CPU or the computer monitor, it gets a little bit warmer, it gets a little bit hotter. Same way happens with your TV or electrical fan or even your mobile phones. When you start playing on it for a longer time, the phone gets heated up. So what is happening? The one disadvantage of electricity is that whenever electric current passes through a resistance or a wire, it is some amount of current which has been resisted by the resistor, means blocked by the resistor, is dissipated. It just not keeps it with itself. It's going to remove that extra current which it had blocked or resistor. The resistance is going to push the current out in form of heat. And with the technical term that we use it here is the dissipation of electric current, and this effect is called as heating effect, and how we have converted this advantage of electric current into advantage. So what is heating effect? If we are taking a circuit where we have only battery connected to the two resistance or three resistance, so it's called as purely resistive, means no other electrical appliances are connected, only the resistance is connected with the battery. So all the current which is flowing is going to go to the resistor. The resistor is going to block it. Okay, and then what is it going to do? It's not going to, this current is not useful, right? It's just being blocked by the resistance. So resistors are going to block it. How much it can block? To an extent it can. After that, as the current gets accumulated, after a point, we'll start releasing it out in form of heat energy. And that is what we call it as. The source energy is continuously getting dissipated entirely in the form of heat energy. And this is known as the heating effect of electric current. And this heating effect is used as advantage is electric toasters, electric iron. So let's understand the physical application, and then we'll go for the examples. So suppose we consider here, okay, the current to be I flowing through the battery and the resistance is R, the voltage is V. It is going to be noted with respect to time, which is very important. Like if you're using a computer for let's say 10 minutes or you're using for 10 hours, the difference is the time. If within 10 minutes your computer is not going to get so heated up compared to 10 hours, right? So the amount of charge which is flowing through the circuit for a given time is what we are going to talk about. So how much work the particular battery is doing, okay, in pushing the electrons or pushing the charge through this circuit in a given amount of time. So with respect to time, how much work is done, that is termed as power. The rate of doing is called as power. The rate of transferring, the rate of work done in pushing the charge across the circuit is called as power. So power is equals to work done with respect to time. So work done or potential difference in electrical terms is V into Q divided by T. The amount of work done will be VQ upon T. We know that Q upon T is current, that is I. Okay. Now by Ohm's law, we are using this. What is the definition of energy? First we'll understand, and then we are going to change this the formula of power by using the different various forms of Ohm's law. Okay. So the heat which is released, which we already talked about, the resistor is blocking some amount of current and this is dissipated in form of heat energy. So the energy which is released is nothing but the amount of work done with respect to time. That means the power and time. So product of power and time is nothing but energy released. So energy is equals to P into T, and P is VIT. Sorry. So now VI is the main formula for power. We can change it by using the Ohm's law, because we know that V equals to IR. So if we are just substituting V equals to IR, we get energy is equals to, in place of we are putting IR. So the final formula for energy we get is I square RT. Now here we can say E, or it can be H, because the energy which is released is always in form of heat. So heat energy is equals to I square RT, and this law is called as the Joule's law of heating. What does the Joule's law of heating says? The amount of current which is flowed, the amount of heat which is being released by the resistor is directly proportional to the square of the current for a given resistance, directly proportional to the resistance for the given current, and the time taken. Okay. So what is power? Power is the amount of work done in given unit time, or the rate of doing work. And what is energy? The amount of work done. That means the amount of power which is dissipated, the amount of current which is dissipated with respect to time. So energy is equals to power into time, and power is equals to VI. Okay. Now we are going to talk about the practical applications of heating effect. We know that the heat is going to be released in every electric circuit, and it's unavoidable. And this is going to damage our components, because wherever heat is released, it's going to increase the temperature of electric circuit appliances. The components will get heated up, and after a point they may get damaged. Okay, so we are trying to make some appliances where the heating effect is used as an advantage, like in electric laundry iron, electric toasters, electric oven, electric kettles. Okay, the best example, the simplest usage of heating effect is the bulb. Now, what is a bulb made up of? The bulb is having a filament, thin wires, which are made up of tungsten, because the tungsten, the metal which we are using, should be able to withhold the temperature. It should not melt and break off. Okay, so it's made of tungsten. The two filaments are never joined together. There is a gas which is filled in, which connects the two filaments. Means if the current starts flowing through the filament, from one side of the filament, it will reach the end of that tip of the filament. From there, the gas will connect, the current is passed on by the gas to the second filament, and then the current is flowing back to the source. So this is how the completion of the circuit is taken care of. Okay, so electric bulb is having a filament which will retain as much heat as possible. Once it is retaining, means holding on to the heat, it will get hot. The more hotter it becomes, it will start glowing. How it will start glowing? Because its color will start changing into reddish orange, and then the gas which is around it will get heated up, and thus the glow, and they'll emit light. The filament must not melt at such high temperature. That is why the filament is made up of tungsten, whose temperature of melting is very high, so it can withstand this high heat which is being transferred by the source. Okay, the filament should be thermally isolated, means the filament should get heat only by the passing of the current, but not from outside. Okay, therefore it is being covered by a glass cover or a plastic cover. Mostly it's a glass. A thick glass has always been the top shield of the bulb, any bulb. Okay. Next is, the bulb is filled with a chemically inactive nitrogen. Why we are using an inactive nitrogen or argon gas? Because we don't want the gases to chemically react and they give out some heat energy. We don't want that. We don't want the gases to get affected by the electrons which are flowing through the filament. Therefore, we are using chemically inactive. Okay, most of the power consumed by the filament appears as heat, and only a small part of them is released in form of light. The glowing part of the light, the glowing part of the bulb. So 3/4 amount of the current which flows through the bulb is being consumed in heating up the filament. 1/4 is like comes out as glow light. Okay. The next important application. What is a fuse? A fuse is electrical safety device. Now, if you imagine you're connecting a AC and a fridge and a computer in the same plug point. Okay, and the current is flowing. Now, AC requires more current, whereas the computer requires very less current. But if you both are given the same amount of current, what will happen? Yes, our computer will burn off or it will blast, right? So the same thing happens outside our every home. There is a big electrical box wherein we attach these fuses, which is to safeguard the main electrical connections of our home. At the same time, every room has a switchboard. Inside the switchboard also we have the fuse connected. So it is called as a safety device, which helps in protecting the electrical appliances from damage. From damage of what? The extra current which sometimes flows suddenly through the main electrical wire. So every house, outside the house, we have these electrical poles through which the current is flowing inside the main electric box of our home, and from the main electric box, it flows into the main individual room electric boxes. Okay. So sometimes it may happen that suddenly there will be a high amount of current which will be flowing through the electric pole to our main house circuit box. So we don't want all the appliances to burn off, right? So on inside the electric box, there's a fuse which is connected, which will take care of this extra current. So now if you see the fuse connection, the fuse is having two electric metals. Between the two electric metals, there is this wire. This wire is again made up of very high heat resisting metal like tungsten or alloy, which will not melt at a very low temperature. They melt at like temperature of like say 3000 degrees of temperature, they'll start melting. So when a high current flows into the circuit, this metal will melt and break the circuit. Once the circuit is open, no current will flow through the electric base. Okay, so a fuse consists of a piece of wire which is made of metal or alloy. Mostly it's made of aluminum, copper, iron or lead. The fuse wire is encased in a cartilage, means it is made up of a porcelain cartilage, which is again a non-conducting material, means it's an insulator. Okay, and it has two metal ends as I've already mentioned. The fuse for domestic purposes in our normal smaller electric switchboards, which has 1 ampere, 2 ampere, 3 ampere, and the main board will be having 5 ampere, 10 ampere to 25 ampere fuses, depending on the applications. Okay, depending upon the current that is being used in the house. So how does this work? Okay, so a fuse is connected in series connection always. Why? Because we know that in a series connection, the same amount of current flows through the circuit. If a larger amount of current flows through it, then what happens? The temperature of the fuse wire will increase, okay, and the wire will melt and it will break the circuit. In 2 minutes, I'm just going to show you this, what happens with the fuse which I've connected, and when the current flows through it, what happens with the fuse. The fuse will break. These are the smaller fuses which we use in the appliances. If once it breaks, it will stop the current flow into the appliance. Whereas in the electric switchboard, we'll be using these type of bigger fuses. Okay, clear? Now, let's talk about the last topic and then I'll show you the working of the fuse. Electric power. What is electric power? Power means rate of doing work. Electric power means again the same definition. When an electrical work is done, means in an electric circuit, the amount of work done by electric circuit in pushing the electrons across the circuit is called as electric power. The rate of doing work in general means power. But the rate of consumption of this energy or usage of this energy, which is released by the electrical appliances or the electric circuit, is called as electric power. So we know that power is equals to VI. By using Ohm's law, I can substitute V as IR, so IR square, or I can substitute I as V by R. So V can be substituted, as what? V can be substituted as IR. So I get my I square R, or I can say I is equals to V by R and I'll get V square by. So these are the three formulas for power. The SI unit of power is watt, which we use. In general, in our day-to-day life, we call it as kilowatt because they are larger units. So 1000 watt is called as 1 unit. So if I'm talking about 1 ampere current flowing through this device and the potential difference is 1 volt, then indirectly we are talking about 1 watt power. So what is 1 watt power? 1 ampere current flowing through the circuit or the electrical appliance with a potential difference of 1 volt. So 1 watt is 1 volt multiplied by 1 ampere. The larger unit is 1 kilowatt. So if you are using about electrical energy, power into time, 1 watt in 1 hour. So 1 watt hour, which is also called as 1 unit. In our day-to-day life, we call it as the 1 watt hour as units. Okay, and it's a very large unit of electrical energy. And it's called as kilowatt hours. Not even watt hour, it's kilowatt hours. Kilo means 1000, right? So 1 kilowatt is 1000 watt multiplied by 1 hour. So 1000 into 3600, at the end of the day, you get 3.6 into 10 raised to 6 joules. As you can see here, I've used a very high voltage battery and the fuse is connected here. The moment I put on the key, watch what happens. Can you see the fuse disconnected? This is how the fuse works in breaking of the circuit.